Hello everybody, welcome to the next video in our GMAT Ninja Quant series. My name's Harry Duthie and today we're going to be talking through some of the word problems. This is the first in our mini series of word problems videos. Now in the coming weeks we're going to be looking at problems that are related to individual topics. We'll have a video for ratios, we'll have a video for percents. I think we'll have a couple of videos for work rate and time problems. But today we're just going to look at those general word problems that don't really fit into any topics. We'll be looking at how to translate those questions into algebra. Now, the video today is not going to have anything that'll blow your head off. So if you're already getting a 48 or a 49, or you're aiming for a 50 or a 51, we might not have a huge amount for you. But if your quant score is in the 30s or the 40s and you're struggling with these word problems, then stick around and hopefully we'll be able to help you out a bit. Now, specifically, we'd say this video is for you if you're struggling to get these word problems started, if you're just sitting staring at a great big wall of text and you don't really know what to do with it, or you're not sure why you're missing these general word problems. Like we say, we've got later videos coming where you can look at individual topics, but if you're just sitting looking at a word problem going, I don't know where this fits. It's not a ratios problem, it's not a percents problem, it doesn't have overlapping sets in it, but I'm still getting it wrong, then this is the video where we're going to look at some of those problems. I suppose both of those topics fall under this. If you know everything, if you know the formulas, if you know the techniques, but you're still struggling with these problems, then maybe this is the video for you. Now, today I've got 8 questions for you, and each question we're going to get up on the screen. We'll give you a couple of minutes to take a look at it, and then we'll come back together and I'll show you how to solve it and what to think about in each of these questions. Now, what we'll cover today is, well, to begin with, just how to convert these word problems into what we might call math speak. As I say, you're going to get a huge, great wall of text, and we're going to need to convert it into some form of algebra. And then we're going to look at what to look for in the text of the question. There are some clues that they give you, and we'll take a look at what to look out for. And this bit, how to follow instructions literally. In a lot of these problems, the difficulty comes in trying to interpret what was said. People get very uncomfortable when you're trying to be as literal as possible. But most of the time, that's what we're aiming for. Now, there are times when that's not appropriate, and you've got to keep your human brain on at all times and make sure you don't get caught out. Now, I'll be very clear here with a giant caveat. The GMAT is not setting out to trap you. They are not trying to trick you. But you have to read the questions carefully so that you don't trick yourself. As I say, I'll say this one more time, the GMAT is not setting out to trap you, so don't second guess yourself. If you get to an answer and you've done everything right, then that's the answer. You don't second guess yourself and say, well, I've done everything right, but they must be trying to trick me. They're not. They're trying to write questions carefully and unambiguously, and it's your job to be as literal as possible so that you can understand what you're being asked to do. Now, in this video, we're going to ramp the difficulty up towards the end, but the first couple of questions are going to be very basic. This is just about getting the basic techniques in place to understand exactly what the question is asking for so that you can translate literally into algebra. So I'll put the first question up on the screen now, and I'll give you a couple of minutes to work through it, and I'll see you back here soon. Okay, I hope that's been enough time to take a look at this one. If you need a few more seconds to finish this question off, feel free to pause the video now. We'll still be here when you get back. I'm going to take the question away now, though, so that we can take a look at it together. All right, now, first question with this, as we said earlier, be literal. And we're going to get to that in a second. But the first thing I'd like to take a look at in this question is how you define the variables you're going to use in this question. So you've got to be very careful with making sure you're consistent. One of the problems people have when they're doing these questions, one of the problems my students have when they're doing these sorts of questions, is they allow the variable to change as they're working through the question. So I'm going to be a little bit more explicit. I'm going to take a little bit more time. And I'm going to say that in this question, I'm looking at Annika and Badsha and their ages. So I'm going to use A and B as my variables. I'm going to say A is Annika's age now. And I'm going to be very clear about that. B is Badsha's age now. And I want to stick with that. A and B are their ages now. And so we can work through this question sentence by sentence, going very literally. So this first sentence, Annika is 18 years older than Badsha. I can turn that into algebra by saying Annika is just A is B plus 18. Annika is 18 years older than Badsha. Get into the second sentence. In 5 years, Annika will be 3 times as old as Badsha. Now, this is where this definition of the variables in that this is their age now. Because what I'll see a lot of my students do with this sentence is to say, well, that just means Annika is 3 times Badsha. Say, well, no, because this says Annika's age now is 3 times as old as Badsha's age now, which is not what this says, in 5 years' time. So this line here, that's not right. What we should say is that in 5 years' time, this will be Annika's age in 5 years' time, and that is 3 times what Badsha's age will be in 5 years' time. And so I've got the equation down here. I can simplify this to make it a little bit nicer. And I end up with Annika is equal to 3 times Badsha's age plus 10. And so what we can say at this stage is we've got 2 simultaneous equations here. I've got an A equals in both of them. So if I make the other sides equal to each other, I could say B plus 18 is equal to 3B plus 10. If I take away a B from both sides and then take away 10 from both sides and divide by 2, I'll end up with Badsha's age is equal to 4. Taking that B equals 4 and plugging it back into number 1, I should be able to see that Annika's age is 22. Now, again, another place that lots of my students will trip up is they'll be like, right, these are the answers. I've got an A and B, 22 plus 4. Well, that give me 26. A is my answer. But yeah, what is the question asking you for? And what have you meant by your variables A and B? Question is, what will the sum of their ages be in 5 years? So now I could say the question is really, well, what's A plus 5, Annika's age in 5 years' time, plus Badsha's age in 5 years' time? Well, I've got my A and my B. That's 22 plus 5 plus 4 plus 5. Annika's age in 5 years' time will be 27. Badsha's age in 5 years' time will be 9. And my actual answer is 36. So the correct answer to this question is C. So the things you can take away from this one are, first of all, as we said throughout, we will say throughout this video, be literal in what the question says. You can convert step by step the text into this math speak. But then the other point from this question is be very careful about what your variables are, what they refer to, and make sure you're consistent with that throughout. The danger here is that you might say that A is Annika's age now, but in another equation say A is Annika's age in 5 years' time, and now you've got one variable meaning 2 different things and you're in trouble. So be very careful with what you want your variable to represent. All right, that's our first question done. I will get the second one up on screen now. This will still be another relatively simple one while we're getting into the swing of things. The difficulty level will ramp up a little bit later on. So let me get this question up on the screen and I'll see you back here in a couple of minutes. Okay, now's the time to pause it if you need a little bit more time to work on this one. I'm going to take the question away so that we can look at this together. Right, so one of the other styles of question that the GMAT throws at us in this sort of general word problem sense is these ones where they give you a new symbol and put a rule on it. We're going to see that a couple of times today. This is the first one. Now, in this question, we're just talking about positive integers. So for any positive number, there is a rule. Now, all it depends on is whether or not the positive integer we're looking at is a prime number or not. So if it's a prime number, we do the first thing. We take the number, we multiply it by 2, and we add 1. If the number that we're looking at is not a prime number, then we put it through the second equation, we take the number, and we multiply it by 3. That's all that we're given at this stage, and we're asked, what's the value of 12 with the hat on plus 29 with the hat on? So we need to apply the rule to 12 and 29, and then we need to add whatever the results are together. So let's take a look. If we say our question is going to be 12 with the hat on plus 29 with the hat on, first job, let's take a look at the 12. We need to decide whether 12 is prime or not. Now, we could say that 12 is 12 times 1, but also 4 times 3, 2 times 6. 12 is not a prime number, in which case I'm going to put it through this second rule. I take the 12 and I multiply it by 3. 29, on the other hand, 29 is a prime number. The only way you can split 29 up is to say that it's 29 times 1. So because 29 is a prime number, we put it through this first rule. So 29 with the hat on is 2 times 29 plus 1. And I need to add the results of those two numbers together. All right, let's simplify this. 3 times 12 will be 36. 2 times 29 is 58 plus 1. So I'm ending up with 36 plus 59. Or in other words, if I put 12 through the rule, I get 36. If I put 29 through the rule, I get 59. Add those two numbers together, so 36 plus 59 will give me 95. Now, this is the point where it's good to be careful, not necessarily slow down, although for most people that tends to be the thing that helps here, that if you're rushing, we'll go, right, my answer here is 95. Oh, there's a 95 over there. Well, I'll just click D and be done with it. And they don't notice that 95 also has the hat on it. And so for all the answer choices, we can't just say that they are 25, 41, 47, 95, 123. You have to apply the rule to each of the answer choices to know what they really represent, because this 95 doesn't have the hat on it. The sort of counter to that is you could say, well, why can't I put this backwards through the rule? And follow up to that is you don't really know which way it's going to go. Well, is the number that gets to 95, is it a prime number or is it not a prime number? We don't really know at this stage. So it's far better, usually far more efficient, to just look at these, push them through the rule and figure out, well, what does the answer 25 with the hat on, what does that really mean? So quickly going through these, 25 is not a prime number. Yeah, it's 25 times 1, but also 5 times 5. And so when it's not a prime number, we put it through the 3p rule. So A is actually 75. That's not what we're looking for. B is 41 with a hat on. 41 is a prime number. So I should multiply that number by 2 and then add 1. So B is really 83. And that's not what I'm after. 47, another prime number. So times it by 2, I'll get to 94 and add 1. And so that's the answer that I'm really looking for here. This is going to be 95. 95 is not a prime number, so I would multiply that by 3 and I would get 285. And 123 is also not a prime number, so I'd multiply that by 3 and get 369 if you wanted to carry this one right through to the end and just make sure. But as soon as we hit that 95, we're going to find out that the answer here is C. So in these questions, when they give you a new rule, and it's just a chance to take your time and be careful with them. Generally, what you'll find in these word problems is that once you get the equation or whatever it is, the expression down on paper or up here on the board in our cases, then the actual algebra behind the problem is not very difficult. The challenge with these questions is deciphering what they're giving you. So in order to maximize your chance of success, just take your time. Don't rush that point. Don't feel under pressure to get your pen on paper and get writing. Read the question, understand exactly what it's asking you to do. Make sure you don't miss these hats on the answer choices in this case. And as you'll see, the actual algebra, the actual arithmetic behind these problems is not that hard. All right, we're going to get into some different types of problems in a second. I will get the third one up on the screen just now. I will see you back here in a couple of minutes to look through that one. Okay, as we've done before, now's your chance to pause it. If you need a little more time on this question, I'm going to take it away so that we can take a look at this one together. So there's a few things to look out for in this question before we jump into any of the algebra. The first thing is the way that these two things, salary and number of years employment, the question says that they are directly linked. Now, there's a couple of clues in how they're phrasing these things: directly linked, linearly related. What you can do there is almost jump or straight to, or one of your options is, this could be a straight lines question. Now, if you have a look at the formula we've been given here, D is 3.6y plus 45. Yeah, the letters have changed, but this is very similar to your y equals mx plus b setup that you are hopefully used to now from doing lots of coordinate geometry. So when you see the words directly linked, just let your mind think about, is this a straight lines question? In this case, we don't have to worry about it. We can just use algebra here. But there's another option. We could, if we wanted to, we could think about straight lines in this. So what we're given here is that we're told that, yeah, that the number of years you worked is directly linked to your salary. And we're given this formula for somebody's salary. And what we're asked for is, according to the formula, how much greater is Thomas's salary than Sylvan's? And so, given that it's a data sufficiency question, I will set up my AD over BCE over here. But we could ask ourselves, what is this question really asking about? Now, the salary, the letter we've been given for the salary is D. So I'm going to stick with that. Again, minimize the number of variables you use, make things as simple as possible. And I want to know how much greater Thomas's salary is than Sylvan's. Or in other words, I want to know what Thomas's salary is and then subtract Sylvan's. Now that subtraction, the difference there, that will tell me how much greater Thomas's is than Sylvan's. So that's really what I'm looking for. But since I've got a formula for these, I could change the question slightly. I could push the question and say, well, that is the same as saying, if I put Thomas's, or if I use the formula for Thomas's salary, well, that's the same as saying, well, 3.6 times YT, if that's the number of years Thomas has worked at the company, plus 45, take away 3.6 times YS plus 45, if that's the formula for Sylvan's salary. Now, I can simplify this: 3.6 YT plus 45 minus 3.6 YS minus 45. And that's really what I'm looking for in this question. I've got a plus 45 and a minus 45, so they can cancel each other out. And that leaves me with 3.6 yt minus 3.6 ys. And I've got a common factor of 3.6. Now, so far, each line has been equal to the one above, which makes sense. But this is a data sufficiency question. And what I'm really asking as I'm doing this, as I'm going line by line, is what would I need to know in order to answer the question? So I can take this one more step and say, I don't really need to know this 3.6. I mean, I know it's in there, but what I'm really looking for is the difference between the length of tenure they've had, how many years they've worked at the company. I know that this line is not the same as the one above. You're not going to get the same number for that question mark. But yeah, this is data sufficiency. That's not important. The question I'm asking myself is, what information would I need to know in order to be able to answer the question? The question is, how much greater is Thomas's salary than Sylvan's? But if I know how many, or not individually how many years they've worked, but if I know the difference in how many years they've worked, that's enough. And then that should help us in answering the question. Now, I'll redo the ADBCE thing since I rubbed it out above here. And if we look at piece of information number 1, Thomas has worked at the company for 6 years longer than Sylvan. Well, that is exactly what we're looking for here. YT minus YS is how much longer Thomas has worked at the company than Sylvan, and we're told it's 6 years. That would be enough information to answer the question. So number 1 is sufficient, and I will cross out B, C, and E. Second piece of information, well, we're told Sylvan's salary is 81,000. Now, if I knew Thomas's salary, that would be enough, but I don't. I can use this to work backwards through the formula to figure out how long Sylvan's been at the company. But again, from number 2 alone, I don't know how long Thomas has been at the salary. So knowing information about Sylvan by himself, that's not enough for me to know the difference between the two salaries, how much greater Thomas's is than Sylvan's. So that is not sufficient, and my answer is A. So the things to look out for in this question are things like, if it says directly linked or linearly related or some variation on that, then you might want to think about straight lines. We don't need to hear, but it's another option, another way through the problem. The other thing is, in a data sufficiency problem, keep thinking, can I push this question a little bit? What information have they given me, and can I take this further? This question, or the way that this question's worked out, if you can get from what's the difference in the salary to what's the difference in tenure, well then number 1 and number 2 fall out very quickly, and there's not much work to do left. Right, we're going to take this on. I will get the next question up on screen, and I will see you back here in a couple of minutes for the next problem. Okay, here's your chance to pause this one if you need a little more time working here. I'm going to take the question away right now. Right, so what we've got here is these questions are beginning to get a little more difficult in how they're phrased. Now, one of the things we find with students is that they begin to panic with this. That deciphering the question takes so long that they begin to worry that they're going to run out of time to to do other questions. It's just, this is taking too long. I need to rush. Now, one of the things I want you to take away from today is that by the time you get the algebra on screen, you're most of the way done. The algebra in these problems is not especially difficult. And if you can stay calm, if you could just read the question, decipher the scenario, then you've got the time to get the algebra done before the end of the problem. So let's take a look at what's going on here. So we've got a team washing cars, and we know that in order to meet some quota, they have a quota that they need to wash 4,200 cars in the next 3 weeks. They initially had a plan to clean 700 per week, but for whatever reason, we're not told, they've only managed 550 per week until now. And we want to know, and this is the important bit, how many weeks in total did the team have to reach their quota? So I'm going to try and minimize the number of variables I use. I want to use one here. I have one unknown. I'll call it X, and that's the number of weeks the team had to reach the quota. And in order to answer a problem like this, you begin to think about what can I do? What can I use that unknown for? Now, in this case, we're sort of being told that the team had two different ways, two different routes they could have taken to reach this quota. They could have cleaned 700 cars a week, but instead they cleaned 550 per week, and now they've got to finish up with 4,200 in the last 3 weeks. The one thing we do know is in order to reach their quota using either path, the total number of cars they clean will be the same. So we can use that to set up two sides of an equation. Now, the easiest side is what would have happened if they had stuck to their quota? Well, they'd have done 700 cars per week, and they'd have cleaned that number of cars per week for X weeks, which would have given them a total of 700X cars. And that is the total number of cars they could have cleaned. Now we've just got to map that onto the other side and say, well, what's happening now that they've gone down the other path, that they've only done 550 until now, and we need 4,200? Well, that 4,200 is in the final 3 weeks. Up till now, up until the final 3 weeks, so a total of X minus 3 weeks, they've cleaned 550 cars per week. So we could say that 700X is equal to 550 times X minus 3. That's up till the period we are at now in this scenario. But then now they've got to get to 4,200 in the next 3 weeks in order to make the two sides of these equations the same. As I said, this takes a bit of time. This takes a bit of thinking. You've got to read that question carefully. But now that we've got the algebra down on the board here, you can see this equation isn't very difficult. And the actual algebra here should be fast. So when you're reading these questions, just because it's taking you quite a long time to get to the algebra, please don't panic. Please don't think that you're going to dramatically run out of time. It might be that by taking your time, you can carefully get this algebra here, and then the algebra will fall out nice and quickly. So let's finish this problem up. What I can say straight away is, well, I could divide every term by 10 to make the numbers a bit nicer. And then if I expand this set of brackets in the middle, I'll get 55x minus 165 plus 420. If I take all the x terms to one side, so if I take away 55x from both sides, I'll get 15x, and 420 take away 165 would leave me with 255. Now, I'm going to pause here. Now, if you know your 15 times table very well, let's go get the answer. Just go for it straight away. Don't worry about it. But that sort of division, this kind of number, begins to intimidate some of our students. Another thing we can do here is to say that nobody's ever going to see you working. If you think about how the exam works, you're either going to do it at home on a whiteboard, or you're going to do it in a test center on one of those whiteboard style pads. And once you're done with it, you're going to rub everything out. Nobody's ever going to see what you've done here. So it doesn't matter if you take 1 step, 3 steps, we might not want you to take 10 steps, but as long as you get to an answer in the quickest, most efficient way. Now, what lots of my students will do here is go, what's 255 divided by 15? And their brains almost just go into overload because they don't know the 15 times table. But what we could say is, well, do we know a number that divides both 15 and 255? Well, it looks like 5 would. So let's just divide both sides by 5 and not worry about getting to an answer in one step. Now, if I divide both of these by 5, I'll get 3x, and 255 divided by 5, it's 51. It might not be a nice division, but it's still nicer than trying to divide it by 15. And now yeah, I've got a 3x and a 51. Well, and we're going to get to an answer that's going to be a whole number, I'm going to divide both sides by 3. So the left-hand side is going to be x, and 51 divided by 3 will give me 17. And so the answer is going to be B here. But I hope there's a couple of things that we could take away from this. The first is that, yeah, it might take you a bit of time to get to an answer. Sorry, not to an answer, but to get to the equation that you're setting up. As I said here, yeah, 700x equals 550x minus 3 plus 4,200. It takes a bit of time to get there. But in these problems, that's okay. The challenge in these problems is deciphering the text and turning it into algebra. Once you get there, the algebra behind it is not that hard. The other thing, and this is a little bit of an aside that, yeah, it's not really relevant to this video, but can be very helpful, is when you get some fairly nasty arithmetic, don't feel that you've got to do it in one step. As I said, nobody's ever going to see the working you've done in this question. Nobody's ever going to know how you've got to an answer. The important thing is you get there efficiently and accurately. And if that means breaking the problem down so you do it in steps, that's absolutely fine. Do it in the way that gets you to the correct answer in the most efficient and accurate way. All right, I will get the next question up on the screen now, and I will see you back here in 2 minutes so we can go through the next one. Okay, there's a lot of reading in this one. I hope you've had time to take a look at it. If not, now's your chance to pause it before we take a closer look. I'll take the question away now. So, as I've just said, huge great wall of text here. We've got a lot of reading to do. Let's take a look at what the question's asking us. So, yeah, data sufficiency questions. So I'll get this AD over BCE set up, ready to go. And we know that when booked, a vacation rental rents for X dollars per week for 16 weeks in the summer. So being very literal with this, I could jump in and start going, right, my question is going to be, or I can begin creating an equation, X dollars a week for 16 weeks in the winter. So 16 times X, that'll be the amount of money I get in the winter. And it's 1.5x dollars per week for 20 weeks during the spring. So I could add 1.5x times 20 in the spring and fall, and 2x dollars per week for 16 weeks in the summer. So 2x times 16 in the summer, and that's what I'm looking for. And we're asked, how much revenue did the rental generate last year? So looking at this, if this was a data sufficiency question, we might begin to say, okay, well, I can simplify some of this. That'll be 16x plus 30x plus 32x. And that would be what, 46, 70, 78x is something. But since this is a data sufficiency question, all I really need to know is x. But is that really what the question's asking here? So if we're saying how much revenue did the rental generate last year, and let's just take a look at winter, the first bit, X dollars for 16 weeks in the winter. You might think we just need to know X, but really is it not? We need to know X and we need to know how long it was rented for. And all I've done with this equation is dive in and say, well, looking at that first term, just that it definitely is rented for all 16 weeks if I'm going to calculate 16x. But I don't know that. So this is one of those questions where, like, as with all the others, yes, read it literally. There is the possibility of getting an equation here, but don't get sucked in, go robotic and just go automatic. Don't go just into some sort of automatic mode. You're like, right, there's an equation coming. Let me create the equation. You've got to keep your human brain in there and just keep thinking, what have I been told? What have I been given? What haven't I been given? How is this question working? Because if we head down this path, we may end up going down the wrong path. We may end up ending up with the wrong answer. Really, not only do I need to know what X is here, I need to know when the holiday, or how long in the year this rental was booked for, and how many weeks in the winter, how many weeks in the spring and fall, how many weeks in the summer, because those are going to get different rates. So there's an awful lot of information I don't have here. Now, what we're looking for is, how much revenue did it generate? Well, let's see if we can figure that out for number 1 and number 2. So if number 1 tells us the rental was booked for 46 weeks last year, on the face of it, that might look very helpful. But as we said earlier, it's a different rate. It's X dollars a week for 16 weeks in the winter, 1.5x for the spring and fall, and 2x for the summer. This 46 weeks, how many of them were in the spring? How many of them were in the summer? We can't tell that from the information we've been given. So number 1 by itself is not sufficient. And so I should cross out A and D. Now, number 2 tells us if it's booked for the whole winter, the rental can generate $16,000 in revenue. And this is the sort of thing that can be a little bit helpful. If it's booked for the whole winter, then that's 16 weeks of winter at X dollars per year, and that would equal 16,000. Well, the 16s would cancel and X would be 1,000. Well, at this stage, I know that X is 1,000, so I know that we make $1,000 per week in the winter. I know that we make $1,500 per week in the spring and the fall, and I know that we make $2,000 per week in the summer. But for number 2, I have no idea about how long it's been booked for in the year, what the breakdown is of that booking. I just know what the value of X is. And this is the point that if we fall into that trap of just being literal, if we had just read the question, GMAT's not trying to trap us here. They've given us the information that this is when booked. So there is no trap in the question. It's just how carefully did you read it? And did you fall into your own personal trap of not using your human brain, of just going robotic and going automatic? So number 2, we know what X is, but we don't know how long it was booked for. So that's not going to be sufficient. Now, putting this together, again, I know what the value of X is. So I know what the rental is going to cost for each week. And I know it was booked for 46 weeks last year. But was that 20 weeks in the spring and fall, 16 in the summer and 10 in the winter? Or was it 20 weeks in the spring and fall, 16 in the winter and 10 in the summer? I just don't know. I don't know the breakdown of when it was rented. So just knowing 46 weeks last year and X, that's not going to be enough either. So cross C out. And in this question, we're left with E as the answer. So we've done how many? 4 up till now, where it's saying, be literal. Be very literal. Just take what the question gives you and run with it. This is a bit of a warning, this question. Yes, be literal, but be careful. Don't switch off. Be careful with what they're giving you. They're not trying to trap you. You can fall into your own trap if you are not careful with what you're doing in the question. So if this question trapped you, if you slipped up here, keep that in mind as we go through the final 3 questions for today. Now I'm going to get the next one up on the screen and we'll give you a couple of minutes to take a look at it. I'll see you back here soon. Okay, now's the chance to pause the video if you need a little more time to look at this one. I'll take it away so we can take a closer look. Right, so second question in the row about holidays. I don't know what that says about us, but let's take a look at what this one's talking about. So this is another one. We're back to that kind of be literal. Don't be intimidated by the wall of text. You're given the variables this time, so we don't need to add anything in. And it's just be careful. Be careful with what you're being told. Go, I don't want to say slowly, but go carefully, because once the algebra is set up, the problem itself is not that difficult. By the time the question is set up, by the time the equations are set up, you've got the algebra down on the page, this question is probably about 70–75% done. So don't be intimidated if you're looking at it going, that's a huge wall of text. It's going to take me an awful long time to read. As I said, by the time you've got the algebra down on the page, you're most of the way there, and the rest of the question shouldn't take that long. So what's going on here is that vacation rental, holiday cottage, costs a total of D dollars. And we've got a group of people who are going to share this cost equally between them. Now, some number, we don't know how many, but some number of that group are going to drop out. And so the remaining people, whoever is still going, are going to have to pay a little bit more so that they can go on this vacation, take up this rental. And we are asked, what is the additional amount? As we've done before, we need to be very careful about what we're being asked. So it's not the amount they're paying before the people drop out. It's not the amount they're paying after. It's the additional amount they need to pay in order to get from what they were going to originally pay to what they have to pay now. Or in other words, it's what's the difference between what they have to pay now and what they were originally planning on paying. So the question is really, what's the difference in payment? Now that, we could say, is it's going to be the new higher payment minus the old lower payment. If you think about that, if there's a group of you paying for something spread equally and 3, 4, I don't know, however many, if you drop out, the remaining people are going to have to pay more. The new payment is going to be higher than the old payment. So the additional amount they're going to have to pay is this new payment, take away the old payment. It's going to be the difference between the two payments. So the amount they're going to have to pay, the new payment, well, the amount they have to pay in total is still D. This holiday cottage costs a total of D dollars. That's the amount they have to pay. Now, to split that up between the number of people, we're going to have to divide this. So the new payment is going to be D divided by the number of people we have left. So there were F people initially agreed to go, and G of them decided not to make the trip. Now, again, this is another place where you need to be careful. Okay, if you're reading this at 100 miles an hour, you might think F people were initially going to make the trip and now it's G. But no, that's not what it says. F people were initially going to make the trip, G people have dropped out. And so the number of people remaining is going to be the original number F, take away the number of people that have dropped out. So the number of people we have on the trip now is F minus G. So to find out the amount that each of them has to pay, I would divide the total cost by the number of people remaining on the trip. So it's D divided by F minus G. Then I need to subtract the old payment. Now, the total amount they were going to pay remains the same. That holiday cottage still costs D dollars. Initially, it was a group of F people. So the amount that each of them would have to pay would just be D over F. As you can see, that's taken some time. We had to really think about that. I had to be very careful about what's in the passage. But now that I've got this up here, well, I just need to simplify this. But the equation I've got, the expression I've got is 2 terms. The answer choices are all 1 term. So if I do the subtraction of this fraction, I should, hopefully, get one of these answer choices here. So to look at these two, I'm going to give them a common denominator of F times F minus G. And that means for this first one, I would need to multiply top and bottom by f. So I'm going to have df over f minus g for the first expression. And the second one, to get this common denominator, I would need to multiply top and bottom by f minus g. Well, now I can bring them all into one fraction, and I'll have df minus d times f minus g. And I can begin to simplify this top line. So expanding the brackets will give me df minus df plus dg. The df's will cancel, and I'll be left with dg over f minus g. And comparing that to the answer choices over here on the right, that will match answer choice D, and D is the answer. So one of the things that really is one of the things that really intimidates people in these word-based questions, is the amount of time it takes to get to the maths and get going. They begin to panic. They begin to think that I'm spending far too much time on this question, and it's going to burn up too much time on my exam. It's going to hurt my score. Now, all I'm suggesting you do is to take your time, because as you can see here, as we've seen in some of the other questions here, once you hit the algebra, this is relatively simple. The challenge is getting to this stage. The challenge is interpreting this huge, great wall of text and getting yourself to the algebra. So if you can stay calm, if you can keep your nerve, and if you can just tell yourself, once I get to the algebra, I'm going to be fine. Well, now you've given yourself a chance to get through these questions, and hopefully we can boost your score a little bit. So we had a couple more for you now. I will get the next question up on the screen. We'll give you a chance to take a look at it. I'll see you back here in a couple of minutes. Okay, there's an awful lot going on in this question, so I wouldn't be surprised if you need a little more time to take a look at it. Now's your chance to pause the video if you need a little more time. I'm going to take the question away so that we can look at this one together on the board. So like I say, there's a lot going on in this question. We've got another one of those new symbols. If you think back to question 2, where we had the hat on the P, this time I've got these squiggly brackets around the X, and that's doing something. I've got an algebra expression we need to come up with. We need to figure out the cost for this fencing. But also, hopefully you spotted it, we've got a units conversion as well. We were asked about a perimeter of p kilometers, but the costs that we were given were all in lengths of meters. So we've definitely got 3 things that are going on in this question. We've got a huge, great wall of text here again. There's a fair bit of intimidation in this question. But again, it's another one that once we break it down, we're careful, we're literal, then the actual maths underneath it is not that hard. The challenge is getting to that maths, and that's what we're going to take a look at here. So what we can say is that I'm fencing a field that's got a perimeter of p kilometers, but my fencing charges are all in units of 250 meters. So what we could say to begin with is 250 meters is equal to It's a quarter of a kilometer. So I'm going to pay $30 for each quarter of a kilometer. Well, each additional $30 for each additional quarter of a kilometer or length of fencing up to a quarter of a kilometer. And so we're going to be dealing in units of quarter kilometers. So I'm going to use some numbers to illustrate what's going on here. Now, you don't need the numbers here. If you can think your way through it, that's perfect. But if I'm just dealing with P's and think you might not see what's going on. So I'm going to, in parallel, say, well, we're going to start with P kilometers, and this is the one I'm going to have as my answer. But so that you can see what's going on using some numbers and it's a little bit easier, I'm going to say, well, let's just imagine that we're dealing with 3.1 kilometers. Now, as we've just said, we're going to be charged in blocks of quarter kilometers. And so I don't need to know how many kilometers I've got. I need to know how many quarter kilometers I've got. So there are four quarter kilometers in each kilometer. So I should times both of these by 4. And the units of those are going to be my quarter kilometers. Now, 4 times 3.1, I've got 12.4 quarter kilometers. And yeah, I've still got 4p quarter kilometers. So that is the absolute number. That's the total number of quarter kilometers I've got. But as you can see with this 12.4, that might not be a nice, neat, round, whole number. What the question tells me is we're going to get an initial charge, which we'll get to in a minute. I'm leaving that out for now. We're just looking at this bit about the additional charge or the length of fencing. So I'm going to get charged $30 for each additional quarter kilometer or length of fencing up to a quarter kilometer. So that bit tells me that I will be charged a full $30 for every partial bit of fencing up to 250 meters. So I'd be charged $30 for 250 meter chunk, $30 for another 250 meter chunk. But if my final chunk is only 100 meters, 112, 105, whatever, 63, that final chunk up to 250 meters is going to get me charged the full $30. And that's where the symbol comes in. The x inside the squiggle is the smallest integer greater than or equal to x. So look here, I'm going to deal with the numbers first so that we can see this in action, then we'll move over to the question we're dealing with. If I have 3.1 kilometers, we said that was 12.4 quarter kilometers. Now I will be charged $30 for each of those 12 quarter kilometers, those 250 meter blocks. But I'll also be charged a full $30 for that 0.4 of a kilometer I've got at the end. So my total charge that I would be paying here would actually be 13 times 250. Now, using what we got in the question, we've rounded the 12.4 up to the 13. And so I could say that was the 12.4 in the brackets. Sorry, it's not times by 250 at all. The charge is 30. Times by 30. Now, working my way backwards, that is 4 times the 3.1 we had at the beginning times by 30. And there's my initial length of fencing. So transferring that over to this side, I don't know what P is. I don't know if it's a whole number of kilometers or it's a quarter number of kilometers or it's something like 3.1 or 2.2 or something strange. But what I can say is that in order to get the full charge, I should put in squiggly brackets the 4 times the number of kilometers I have. So 4p in the brackets times that by 30. And so that would give me the charge for the total distance of fencing. And now we need to deal with this bit at the beginning. Company charges $240 for the first 250 meters it stalls, then plus $30 for each additional 250 meters. So this bit is not quite right because we have counted that initial 250 meters in our charges of $30, whereas the first 250 meters should actually be charged 240. So I'm going to get rid of the numbers for now. We're saying that it should be 4p in these strange brackets times by 30. But I want to add on the 240 it cost me initially. And my problem here is that I've counted that first 250 meters, that first quarter of a kilometer, I've counted it twice. So I need to take one block of 30 away from this to count for that. And so this will be the charge that the charge the company makes for installing a fence of P kilometers. Simplifying this, 240 minus 30 will give me 210, and I would add on the 4p in the brackets multiplied by the 30. Now, comparing that to the answer choices, that will give me an answer of A. So in these questions, you don't want to pick numbers randomly. What I've done here is I have chosen one number in order for me to put it through the process so that I can understand the system and get to something that I can translate into algebra to get me to an answer. Now, if you don't need that, fantastic. Go and get after it, get to the answer and work your way through. This is just one method you can use to better understand the question. Now, again, it's another one. As you can see, the translation of the question into algebra is the challenge. Once we get that initial expression for the charge, it's a one-line question, but it's just getting there. There's an awful lot going on in this one. As we said at the start, we've got the new symbol, we've got the change of units, and we've got the problem of actually figuring out the charge going on here. Once you're down on paper, once the algebra is there, you're a line or two away from finishing. So take your time and don't be intimidated by the wall of text and how long it takes to translate that to algebra. All right, I've got one more question for you. As you can see with this one, we're beginning to build up a little bit of a challenge here at the end. So hopefully this one pushes you a little bit. If you found the rest of the video easy, hopefully this one gives you a bit of a challenge, but I'll see you back here in a couple of minutes for the final question of the day. Okay, for the final time today, now's your chance to pause the video if you need a little more time to look at this one. I'm going to take the question away so that we can take a look at it together. So, yeah, by now you're probably tired of hearing me talk about, yeah, let's read the question carefully, let's be literal with what we're saying. I hope you remember from way back when, early on in this video, this bit about linear relationships. We're told that there is a linear relationship between the number of new clients signed in a given year and the size of that employee's bonus, which means that we are working with something resembling a straight line. We're going to be using that straight line formula here. One of them's the y, one of them's the x. Unless there's anything that tells us in the question, we can make the choice about which one we make y, which one we make x. We know that signing 46 clients, new clients, will lead to a bonus of $80,000 and 22 clients will lead to a bonus of $20,000. For our relationship, that gives us a set of coordinates. And the question asks us, a bonus of $70,000 corresponds to what number of clients? So the question here is what number of clients? Because of that, because that's what the question's asking, I'm going to make the y value in this relationship that's going to be the number of clients, and the X value, that's going to be the size of the bonus. Now, if the question had told me to do one or the other, make the X value the size of the bonus or make the X value the number of clients, I'd have done that. I'd be given the freedom to choose which one I want to be which. And because the question asks for the number of clients, that's what I'm going to make my Y value. It just makes the algebra a little bit more simple later on. In which case, I've got to be very careful with how I set these up as the coordinates for my equation. So I said that the Y value is going to be the number of clients. So if I look at the 46 and the 80 first, I'm going to change the size of the bonus from 80,000 to 80. Again, it just makes the algebra easy. It will still work if you leave the X value as 80,000, but the decimals or the fractions are going to be a bit nastier. So I'm going to say that my X value, the size of my bonus is 80, means that I had 46 clients signed in a given year. Similarly, with the 20 and the 22, the X value is going to be 20. That's the size of the bonus, and the Y value is going to be the number of clients. Now, what I'm looking for is what number of clients leads me to a bonus of 70,000. So I need to find the equation that goes with this straight line, this linear relationship. Then I can plug in an X value of 70, and that'll tell me the number of clients. So we're back to coordinate geometry here. I've got my two coordinates. What I need is the slope, the value of the slope, and the value of the intercept. Well, I can find the value of the slope by doing, well, what's the difference in the Y values divided by what's the difference in the X values? Or in other words, that's going to be 46 minus 22 will give me 24, 80 minus 20 will give me 60, dividing both top and bottom by 12 will give me 2 over 5. So I know that this relationship is equal to Y is equal to 2 over 5 X plus B. Now I need to find the value for B here. I need to find the Y-intercept. I'm going to plug the 20 and the 25 into this equation, and that'll give me the value I'm looking for. So the Y value is 22. That's 2 over 5 times 20 plus B. 2 over 5 times 20 should be 8. And so B is going to be 14. So my relationship here, the equation of the straight line that links the number of new clients signed and the size of the bonus is going to be Y is 2 over 5 X plus 14. As I said, what I'm looking for is my number of clients, is my Y value. I'm looking for that Y value when X equals 70. And I can plug that in. I'll move up over here. So Y is 2 over 5 times 70 plus 14. Well, 70 divided by 5 is 14, times by 2 is 28. 28 plus 14 will give me 42. So the number of new clients I would need to sign to get a bonus of 70 is going to be 42. And so my answer for this question is B. Now, as we said before, huge great wall of text here, and there's a little bit more going on here. The thing to notice straight from the beginning is that comment about there being a linear relationship. That leads you into thinking about straight lines, or should lead you into thinking about straight lines. We have a linear relationship between the size of the bonus and the number of clients signed. After that, you're given two coordinates. As we say, the 80 goes with the 46, the 22 goes with the 20, and from there, this is just a very well disguised straight lines question, coordinate geometry problem, and you're looking to find the equation of that line and then plug one value in. So with all these problems, as we've seen, that there is just a need to take your time. Think about what is the question really asking you and what information is it giving you. As you've seen throughout, once you get the algebra onto your page or up on the board here, the actual mathematical process behind it has never been that hard. The keys here are don't get intimidated by the giant wall of text. Take your time, be careful, define your variables carefully, read carefully, be literal in what it says. But as you saw in that middle question, don't forget to keep your human brain turned on. Right, so as we said, that this was all about general word problems. Over the next few weeks, we're going to get into word problems that are relevant to a specific topic. So we'll be looking at ratios problems, percentages problems, work rate and time problems, and all the other sort of word-based questions. They will all use the techniques we've used in this video. So if you've enjoyed this, if you struggle with it, if this has helped, go away and practice some of those, and we'll hopefully see you back here in the next few weeks where we use some of these skills in topic-specific questions. I hope that's been helpful, and we look forward to seeing you back here for some of the more videos soon.